Turn on the news and it looks like the world is collapsing. But look back a few centuries and you see a different reality. Most of humanity lived in extreme poverty, cramped in unsanitary conditions, with life expectancies that would shock us today. We have largely escaped those baselines. So why do we constantly feel like everything is getting worse? It comes down to biology. Our ancestors survived by paying close attention to danger. The early humans who hyper-focused on threats lived long enough to pass on their genes. Those who ignored the rustling in the bushes didn't. Now, take that ancient threat-seeking brain and expose it to modern media. News channels and social platforms exploit this negativity bias, serving up a continuous feed of crises, wars, and disasters to keep our attention locked. Our constant anxiety is an evolutionary hangover. It blinds us to the data, obscuring the fact that we have spent the last century solving the very problems that once defined the human condition. Part of our blindness comes from how we measure progress. Human brains are wired to think linearly. We expect things to improve steadily, step by step, at a predictable pace. This chart shows where intuition fails. 30 linear steps equals 30 meters, but 30 exponential steps travels over 1 billion meters. This steep curve is where AI, robotics, and biotech operate today. Progress looks flat, then suddenly explodes upward. Because we project our linear expectations onto exponential tools, we underestimate what is possible. We look at widespread shortages and mistakenly assume they are permanent fixtures of reality. There is a specific mechanical process driving this acceleration. It is called the 6Ds framework. It starts with digitization, taking physical information and turning it into zeros and ones, making it nearly free to store and share. Next comes deception. Early digital growth is so minor it looks insignificant. A clunky prototype camera sits in a lab, and legacy industries ignore it. Then comes disruption. The technology crosses a quality threshold and rapidly replaces the old way of doing things. As it scales, costs plummet. That is demonetization. Software becomes virtually free to reproduce. This leads directly to dematerialization. The physical objects we used to buy, calculators, maps, video players, literally disappear into applications on our devices. The final step is democratization. Think about the computers that guided the Apollo missions to the moon. Those were exclusive tools requiring national budgets. Today, billions of people walk around with exponentially more computing power in their pockets. This 6-step framework acts as a machine. It continuously takes scarce, expensive physical resources and converts them into free, infinitely scalable digital tools. We can apply this exact blueprint to physical survival threats. Take energy. Civilization spent centuries fighting over limited fossil fuels deep underground. Now, advances in solar capture and battery storage are driving down the cost of capturing the vast amount of energy hitting Earth from the sun. The same logic applies to water. Earth is covered in it, but access to clean drinking water has always been restricted by geography. Now, advanced nanofiltration and solar-powered desalination are turning that geographic scarcity into a solvable purification challenge. Look at agriculture. Instead of clearing thousands of acres of forest, AI-automated vertical farming allows us to generate higher crop yields in controlled environments, using a fraction of the land and water. Healthcare is shifting from reactive hospital visits to continuous monitoring through wearable sensors. Education is breaking out of local school districts, granting anyone with a smartphone access to top-tier university lectures and digital training platforms. When energy, computing, and connectivity scale up, global crises lose their status as fatal limitations. They become engineering problems. The logic is straightforward. Because technology makes solutions scalable, the world's most daunting existential problems are simultaneously the world's largest market opportunities. You no longer need a major institution or a government grant to participate. Thanks to cloud computing, open-source AI, and global networks, small teams of DIY innovators can design solutions locally and distribute them globally. When a digital solution costs almost nothing to replicate and serves 1 billion people, profit and social purpose align. This allows modern entrepreneurs to drive global abundance while achieving significant commercial success. Exponential technologies are powerful, but they remain inanimate tools. The engine running all of this is human creativity, persistence, and raw curiosity. The mechanics are clear. Technological progress operates on an exponential curve. Pessimism limits our ability to act, and the global shortages we face are temporary gaps waiting for decentralized solutions. We have to stop asking the fearful question, how will humanity survive? We have the tools. We should be asking, how can we build a better future for everyone? Abundance is not a guaranteed utopia. The challenges are real, but if we choose to combine our exponentially growing tools with relentless human determination, we can engineer a world that works for billions of people.